All right. Circle of radius 6 feet. Find the arc length S. They always use S for arc length.
That's weird.
I know. It seems like they should use L or something. Cut off by a central angle of 18 degrees. So do you know central angle?
Something like this?
Right. It's. I mean, it's kind of like here. I'll draw a central angle of 90 degrees. Okay.
Mm-hmm.
And if this radius here is 6, what would the arc length be of the? Let's answer the same question for an angle of 90 degrees. And I think if we do that, then you'll see kind of what's going on. So this is S, and this is 90 degrees. So how long is S? Well, what fraction of the total circumference is S? Well, first, what is the total circumference?
It's diameter times pi, so it's 12 pi.
Sure, so I'm going to write 2 pi r, and then I'm going to write 12 pi. Okay? And the blue part is what fraction of the circumference?
The blue part is a fourth.
Right, so we would say that's 1/4 c.
Mm-hmm.
In other words,
1/4 would be 3 pi.
right. Okay, how can we get that fraction 1/4 like in a systematic way? Well, if you think about it, 1/4 is 90 degrees over 360 degrees.
Okay.
Okay? Like, in other words, if I put any angle here, and I wanted to find what the arc length was that corresponded to that angle, this arc length right here. And let's give that angle a name. What do you want to call it? About, I don't know, they use theta in your book, right?
Yeah.
Okay, so we're going to use theta. Theta is sort of like a grown-up variable. Okay, so theta, if I want the same relationship that this 1/4 is, I can say the fraction of the total is equal to theta over 360. Does that make sense?
Yes.
Okay, so that kind of tells you how to approach the question.
Kind of.
In this question, theta is 18 degrees.
Okay.
Okay, so I'll draw a new circle for this one. Now 18 degrees is kind of small, right?
Mm-hmm.
Something like that. Okay, so we're looking for S, and this angle right here is 18 degrees. Okay, so the total is, I mean, this is still 6, so the total is still 12 pi, right? Which means S is 18 over 360 times 12 pi. You know how to reduce 18 over 360?
Divide both by 3.
Well, think about this.
Or you can divide both by 6.
What's 36 over 360?
36 over 360. 100.
1 over 10, right? 36 over 360. I can divide both by 36. Right? Okay, 18 over 360 is,
It's gonna be 120.
is half of that, right? Okay, and then 1 over 20 times
12 pi.
12 pi is what? We divide both by 4?
0.05.
0.6, you mean? Anyway, I'm going to divide both by 4.
Okay.
Got it? Okay, so the general like technique is to use this idea right here. Fraction of the total is theta over 360. This works for arc length and it works for area. Okay, so I'll just, as an illustration, we can go back and do this problem right here. What if I wanted to ask you, what is the area of this region? Well, what's the total area of the whole shape? Pi r squared, 36 pi in this case. 6 times 6.
Okay.
All right. So that means this area, same fraction. So we could call this the area of the sector is going to be 1/20th times 36 pi. And you can reduce that.
Okay.
Okay. But the point is that the same line of reasoning.
36 over 20 pi.
9/5. Is that right?
Looks like it's,
Divide both by 4?
Yeah.
Right? Okay, the same line of reasoning works in that the way you figure everything out about this sector right here is you take the fraction that the angle makes with 360.
Okay.
Okay? Got it?
So you just take like you take the angle degree measure, then you put it over. So you just have like 18, then you put it over 360,
Right.
and then you pretty much, after that, you times 12r or 12 pi.
12 pi, because in this case, that would be if you're specifically looking for S.
Yes, that's
Because
what,
in
that's
this
what they're
case,
looking
the radius is 6. But if the radius was, 8,000, you'd multiply by 16,000 pi.
They don't really find the area. They're mostly just looking for like the length of whatever.
Yeah, I know.
size parts they
This
want.
this problem didn't ask for length.
Yeah.
But the line of reasoning of using the fraction works in a number of like geometric
Okay.
ways. Okay, like not even just for circles. Like you can think about like what if I gave
Oh,
you
the parallelogram. You could just cut off one of the triangles and put it on the other side.
exactly right. There's all
And you have
sorts
a
of
rectangle.
right. There's all sorts of ideas where you're thinking about fractions of shapes that are
You could take a
helpful.
triangle of a triangle.
Okay, so look at there's all the work.
Everything.
So it works for arc length and for area and for other shapes, etc. Okay.